Hey, good people, welcome back. This is Arthur Morris. I hope that all is well with you today. In this video, we are going to look at the partial fraction decomposition of a rational expression with a prime repeated quadratic factor in our denominator. So this time we will have a quadratic factor in our denominator that is repeated. So it could be uh, x squared plus 2x plus 7 squared or whatever, but it's a repeated non-prime quadratic factor. So when we set these up, we'll set it up on the right-hand side to be ax plus b plus cx plus d, and whatever else we need if it's more than one, more than two. But here we'll just have two. So we want to write the partial fraction decomposition of this rational expression, x to the third plus x squared minus 6. And notice that we are missing the x to the first term in the numerator. So we'll probably look at adding that in if we need it. And then we have x squared plus 3 to the second. Alrighty, so let's set this up as ax plus b. Now you see this is a quadratic factor here because we have x squared. We can't factor it, so it's prime. And because we have an exponent out here too, that means it's repeated, a repeated prime quadratic factor. So remember with the quadratic factors, we have to have two terms in the numerator. So I have ax plus b over x squared plus 3 to the first plus cx plus d over x squared plus 3 to the second. So remember we have to represent each factor, each exponent, x squared plus 3 to the first, x squared plus 3 to the second. If that was raised to the third power, then we would have one more fraction out there. Okay, let's multiply both sides by the least common denominator. So on the left-hand side, we end up with x to the third plus x squared minus 6. On the right-hand side, I have to distribute the x squared plus 3 to the second. So when I multiply it by the first fraction, it will cancel one of those out. So I have ax plus b times x squared plus 3 plus, when I multiply it by the second fraction, the x squared plus 3 to the second will completely cancel out with the x squared plus 3 to the second. So I'm left with cx plus d. Now we want to clear our parentheses using FOIL or the distributive property. So a times x squared, ax times 3, b times x squared, and b times 3. Alrighty, let's rewrite the right-hand side in descending order, and let's add the missing term of 0x on the left-hand side. So we have 1x to the third plus 1x squared plus 0x minus 6 equals ax to the third. That's the only x to the third that we had. Which is good. We like to see those. Bx squared 3ax plus cx. And then, what else? Cx plus d. No, I'm sorry, 3b plus d. Okay, so we had the ax to the third, then we had plus bx squared, we had 3ax plus cx, and then we had the 3b plus d. Now we should be able to match those up with the terms on the left-hand side using the coefficients, setting the coefficients equal to each other. So ax to the third equals 1. A equals 1. That's good. We already know the value of a. 2bx squared equal to the 1x squared, so b equals 1 as well. We know the value of two terms. Good. Two variables. Equation 3, 3ax plus cx matches up with a 0x, so 3 times a plus c equals 0. Then 4, 3b plus d equals negative 6. All right, so we only need to find the values of c and d. So looking at equation 3, we have 3 times a plus c equals 0, and we know the value of a. So let's use equation 1 and equation 3 to find the value of c. A equals 1, so that means in equation 3 I can replace a with 1. Subtract 3 from both sides. C equals negative 3. All right, and then let's find the value of d by using equations 2 and 4. So equation 2 tells us that b equals 1. Equation 4 says that 3 times b plus d equals negative 6. So seeing that, I can replace b with 1. So I have 3 plus d, subtract 3 from both sides, and d equals negative 9. All right, now when I have a, b, c, and d, I come back up to the side that I created and replace a, b, c, and d with those values. So we have 1x plus 1, a is equal to 1, b is equal to 1. So understood, 1 times x plus 1 all over x squared plus 3. Plus c times x, so negative 3 times x. Plus d, so minus 9 all over x squared plus 3 to the second. And that will be the answer for that one. Again, that's a wrap for this video, good people. I hope you found it to be helpful. Look forward to seeing you on the next one. Thank you.